and welcome to today's session. We're going to give it a minute while everybody starts rolling in and joining. We are absolutely thrilled to have you at today's session of the Speakers Forge Meeting of the Minds. Today is a really technical chat, but it will still be in line with everyone's understanding, so please don't worry too much. We're going to have a talk around microservices, and we're going to hear from Julian and Brandon on respectively how to use microservices and how you can love them without loving complexity, but also hearing from Julian all around serverless development and the history and the uses of that. So as always, the session is recorded. The chat is available to everyone, so feel free to leave us a comment, give us a chat, and see what's happening there. And then if you are super keen and you've enjoyed the session, please be sure to also touch base with us and take a look at our YouTube channel. We upload all kinds of Dariel content on there. The question section will also be open throughout. So the session is being recorded for everyone's purposes. This is going to go live onto YouTube in a couple of days, so keep your eyes peeled for that. So my name is Anine. I am the organizer of the Speakers Forge and oftentimes called the Queen of the Forge, although I'm not sure I deserve that title just yet, so we'll take it from there. If you guys have a question, feel free to leave it through to us. And without further ado, I'm going to hand over to Brandon Pearman, who is an exceptional software developer, also a really great author of the blog Decomposition. He'll give you some more details on that. Take a look at his blog. It's really interesting and he makes some really good points. Also check him out on LinkedIn. So without further ado, thank you so much for spending some time with us, Brandon. And I'm going to hand it over to you.
Hi, thank you. Okay, hi everybody. I'm just going to share my screen here. Okay, there we go. Okay, so as mentioned, my name is Brandon Pearman. You guys can reach out to me on LinkedIn. My blog is devobsession.com. I use that to just put down my ideas, or someone asks me a question, I write the answers there. Yeah, so you can take a look at that. And a little bit about me before we get started. I just want to give you guys a background. So I've been deving for over 10 years in the professional space, mostly .NET. I love microservices, but hate complexity. So today, that's what we want to go into, is how we can build up our microservices and try and avoid the complexity that usually comes with it. In my personal space, I'm a gamer. My main games are StarCraft 2 and CSGO. I love investing, trading stocks, and martial arts. But the background of why we're here today, how I got into this idea of what we're going to speak about, I've done a lot of rewrites. And it's a little bit different to greenfield and legacy maintenance. So with a greenfield, it's fantastic because you're starting from absolute scratch, and the tech, you can reinvent the tech, or you can invent the tech how you see it, and you have to figure out the product, right? You don't know the product. There's a process of discovery that comes with that. With legacy, you know the product, everything's working, but the tech side of things is normally a bit dirty, but you got to kind of sludge through that. When it comes to doing a rewrite, the company knows the product, the devs know the product, it's there. It's already existing, but it feels like a green field because you're doing all the tech from scratch. And in that process, normally you've got something that's working already, but you don't want to completely change it. When people go for a completely new tech stack, it's often a bit scary because the old system, they knew what it looked like, they knew what problems they were. So like, okay, we just want to rewrite this and fix the problems that we had. Sometimes that's not a great idea because the inherent design that you had originally is the cause of the problems. But in this idea of rewrites, there's a number of reasons why companies did it. Sorry, wrong way. Is poor system performance, right? The systems were buggy and slow. But that's actually less common than you would think. The real reason why a lot of these companies did these rewrites is because there was poor developer performance. It was slow to deploy, slow to make changes, slow to add features, difficult to understand, and difficult to keep the developers there because the system was just so difficult that they were just like, you know what, this is too much time and effort for me, and they would want to move out. And then onboarding new developers would be difficult as well. And a lot of these rewrites that I did, funny enough, were actually microservices. That a company had microservices and they want to rewrite their microservices into microservices. Normally we hear about monolith to microservices, and there's a whole bunch of patterns to do that. But I find it kind of weird that a lot of these companies were like, microservices are just so complex, we need to rewrite them. We learned from our first mistake, now we want to redo it. But the rewrite is often, it looks the same as what they did originally because they're too scared to do too drastic changes. So at the end of the day, these companies had lost their agility due to technical issues, and they were struggling to grow because of it. Often when we talk about agility, we talk about the business being agile, being able to look at your business requirements and be agile from that perspective. But if your tech stack is or not just your tech, the way it's built, if that's difficult to use, you cannot be agile because you'll have a threat or a opportunity in the business market, but you can't get to production fast enough just because it's so difficult for your devs to do anything. So that's why today I want to be talking about microservices decomposition, and that's why technical agility is actually more important than having a perfect design. So normally when we're going to design a system, nowadays our big thought is like, do we want a monolith or do we want microservices? And with a monolith, we're like, cool, there's one place that we just put everything in, but microservices, we have to figure out where to put everything. And often when people argue about should we go monolith or microservices, they have this all or nothing approach. Do I build the largest app that I can build, or do I build as many of the smallest possible apps as I can build? And I would say that this is a wrong way to think about this problem. And as a comparison, I think there's another problem that we are all familiar with already, and that's when we're going to look at our classes. Would you rather have one class that has 1,000 lines of code in it, or would you have 1,000 classes with 1 line of code in it? Now, I think most developers would look at this, and if you tried either one of these, you know that both are a bad idea. And you're probably thinking, well, these are my choices. There is a middle ground. I could just have sort of well-balanced classes that I get the best of both worlds. So why do we not think the same way when it comes to the size of our services? Can we not have services that are well-balanced, that are in the middle of them? And some people might argue that they're not actually microservices, but we're not going to define microservices today. But hopefully, if this is not your definition of microservices, you can evolve it into microservices over time. But really, I think the big enemy for me is big upfront design. We're often trying to design the perfect set of microservices, exactly how they're going to look like, and we want to do it in one leap. So we have this big upfront design, and then we go out and we develop them. But this often goes bad. And in my experience, when we've done that, we always have to take steps backwards. And now we have to start joining services together and going this way. Or once microservices are in place and messages are bouncing everywhere, and there's this network in between that's a little bit fuzzy. It's hard to monitor what's going on there and hard to observe. This process is actually quite difficult. And that's why a lot of companies just resort to, you know what, let's just rewrite the whole thing. Let's just scrap it and start from scratch. So like I said earlier, we often apply this idea of an iterative approach to our business needs, but not to our tech needs. So what I'm suggesting here is that we do this with our tech needs, and that we actually have an organic decomposition. We start with our big monolith, and we break it down into smaller pieces, but not like absolutely tiny, and then we break it down more and more as we go. So as we learn more, as we need, and as we grow, it can become more and more closer to our ideals. And you may reach a point that you're like, I don't actually need to go further. What I have in mind of what's ideal, it's actually not necessary. So when we talk about decomposition, what are the points that we need to consider? So the first one, we'd probably all heard of this if you looked at microservices, the idea of bounded context from DDD. And there you can just ask yourself, does the service have a separate business requirement? Second one, I think we often see this. I think I learned this one the hard way. I didn't think of this upfront with a lot of microservices, but the idea of common closure principle and decoupling. Over here, we want to think things that change together should be packaged together. Now, we often think of that maybe with a library or something, but the same thing can be applied with your services. So if you have 3 or 4 different microservices, and every time one of those services change, the others also have to change, and then you have to deploy all of them together, those should probably just be one microservice. And yeah, I've learned that lesson from splitting things up, and then we've got to join them together and join them together, because that becomes very clear. But you can actually, we're going to go through techniques today to figure that out before you split them, because splitting them up and then rejoining them is a bit more work than you would like. And then point 3, I think this is the point that we're going to speak the most about, because this is something I think we tend to neglect in the idea of how we're going to decompose our microservices, is team scale. Is there a dedicated team which will own the new service or new services? Okay, now points that you should not be using when you decide how to split up your services. So the first one is the size of the service. We don't want to be defining a service by a specific set of lines of codes or specific amount of endpoints or whatever. Let the size be the size. Don't be too concerned about that. But by the nature of what you're doing, it will end up being smaller than the monolith, but don't force it. The second one is layers. By this, when you think of building a single application, you'll have your business logic and your data layer. You don't necessarily want to do that with microservices. Like, you don't want to have a business logic microservice and then a data microservice. If you look into microservices a bit more, I think this is a point that's covered quite often. But basically, a microservice should own its own data. Then point 3 is entities. This one is the idea of, if I look at my SQL database and I look at my tables, and I've got a product table and a customer table, it seems obvious that I should, let me have a product service and a customer service. That is not necessarily true. You could do that, but you could also not do that. You don't have to base your services per entity, per service. And then the fourth one is unrelated data. I think sometimes here we feel pressured to have a single service that all the data that service uses is all related or highly related. I think sometimes we can put data together that they're not necessarily operating together at the same time. And that may just be a transition step. But I don't feel like this is something that you have to feel pressured to do. Like, this data they never touch each other, therefore we have to separate them. So point 3 and 4 we're going to cover in detail now as well. So let's start off with this idea of entities. And should you split up unrelated data? Okay, so the idea of splitting up entities, here, so in our example, we've got a product, and you see on our database, we've got a name and a quantity, and the product service is working on that data. This is fine. You definitely could do this. But another way that you could also do this, and some people advocate to do this, is to have a catalog service that has some of the data, and then you would have a separate service, a warehouse service that's got the rest of the data. And then you can obviously join them by or reference each other by the ID. Now, this is also acceptable. So I would say both this and this is acceptable depending on your needs. I wouldn't say you always have to split up your entities. But if it works well for you, then it does. And I feel where I find that this works well is when we have two separate actors on those services. So let's say in the business, there's a department that's building up the catalog, and they're adding all the different products to a catalog, and they got these add commands, add, or update. But then you've got literally people maybe working on a completely separate UI system that's sitting in the warehouse, and they're updating the warehouse information. And you'll see that these two systems may do a get to each other, but they would never update. So this actor would never go and update this database, or vice versa. And I think in this case, it works well. But I think if you had a single actor going through a single UI system, and there was a single page that would update all this information in one shot, there's no reason why you can't put that onto a single service. But let's look at this idea of splitting up entities a bit more. So often what we do when we look at this, I think this is where we often feel a bit pressure to split up our services quite a bit, is we'll ask ourselves, do these properties depend on each other for any business rules, or is there any sort of relatedness between them? If there's not, then we can split them up. So let's imagine you've got a website and you've got this form on the site. You can see I'm not a front-end designer because I'm not even sure if these colors match so well, but this is what our website looks like. And oops, we can now look at this and decide, well, how should we create our backend services to accommodate this form? So we can ask ourselves, do these properties depend on each other for any business rules? And you look through, and you would never create a business rule where the data requires each other or needs each other in any way like this. So there's no business rules. If data gets removed from the database, or if you had to remove one of them from the schema and only save some of it, like the data doesn't care about each other, right? So why could we not do this and have a service for each one, a username service, a user ID number service, an email service, phone number service, and an address service? Because each one of these can have their own data and they operate on their own data. They're in no way related to each other. So if we do this, we have to ask ourselves now, well, when the user clicks save, we're going to get a single JSON payload come through to our backend. So it hits our BFF or our gateway, and now our gateway is going to go and save to each of our services. Great. Seems like a fantastic idea at this point. Everything's working well, until you realize that when this gateway service falls down for some reason, it saves the name, saves the ID number, but then it falls down for some reason. And all of a sudden you have inconsistent data. So when you fetch the data, you've got some stuff, but not others. So that's clearly a problem. We can't do this. So a simple solution to this is we can do a retry. In a retry, we could, I'm not going to talk about the mechanisms here, but you could have a queuing system. You could have the front end retry, or Poly will do retries, whatever the case is, but there'll be some kind of retry system. So the first time it falls over, it fails, the retry system will retry again, and then the second time it will succeed. Great, we've got a solution for that problem. But now the next problem we hit is a bit of a timing issue. And this is a weird one because things look like they're all working, but you get some funny stuff happening, like down the system. And when you look at the data, it's like, yeah, but everything's there, it looks fine. Where you save the name, you save the ID, but at that very point, you haven't saved the rest of the stuff. Someone fetches the data at that point in time, and they fetch some of the new data as well as some of the old data. And now you need to send an email to this person, and now you're sending to the old email address when you thought they had just updated that data. So there's a number of ways around this. But a very simple solution, we can just have some sort of ID where when you save it, we'll update that ID, and then this guy will go, okay, this data is inconsistent, let me fetch again. But obviously that lands up with other issues. What if this, when does this actually get updated? If this data is inconsistent, how long do I have to wait before this becomes consistent? So eventual consistency does add its complexity, but this will be a somewhat of a solution to this problem. Works great. Next problem is also another inconsistency data issue here, where we save all our data everywhere, but one of the services fails. And that failure, if it's a transient error, so it fails because it was just a network hiccup, we just retry and it works a second time, great. Again, retries solves that problem. But what if this is not a transient error? What if this is an error that's coming from the business logic and this service says, I will never accept this, I will never save this information. But for some reason, the business logic is just saying no. So retrying is not going to help there. So in that case, we can do a saga. So the idea of a saga is I will save the data everywhere, think of it like a temporary save. If one of them fails, it'll roll back all the others. There's a compensating action and everything will roll back. So you can think of this like a transaction where either one succeeds or none of them succeed, or all of them succeed or none of them succeed. That's the idea here. Great solution to that problem. Now, all of these ideas are great solutions, and you definitely should be using them when you need them. So I don't think it's anything inherently wrong with using these solutions with microservices, and you'll see them all over the place. But we don't need the solution if there's no problem in the first place. If we had to just have a user just save it and then goes to a single service, all those problems disappear and we don't need the solutions in the first place. I mean, think of some of the problems in computer science, like the two generals problem is not a problem if you only have one general. So we can sometimes solve the problem by not creating the problem in the first place. And I think this is the first major step you should be taking if you're moving towards microservices. Keep the number of problems that you create to a minimum. So the key takeaway with all of that is to start very simple and decompose later. So the next step that I want to talk about is the idea of team scale. So is there a dedicated team which will own the new service? Now, I think this is something that is often overlooked when we talk about microservices, because microservices is this new great thing that everyone wants to do, and you'll have a small team that 2 or 3 developers, and we're going to create this massive microservices architecture because we've heard how great it is. So I feel like that is something that makes microservices a good idea or a bad idea. It's basically the amount of teams you have, not necessarily the architecture on its own. Because I have been hearing a lot of people talk about how terrible microservices are. It's over complex and they just want to go back to their monoliths. And I think this is one of the core reasons why. But if you're a team and you're going to decide, cool, we're going to do microservices, and you start off, you're going to go Google, what are the pros of microservices? You get something like this. It's independently scalable, independently deployable. There's team autonomy and ownership, fast, easy deploys, fault isolation, no vendor lock-in, ease of understanding, and easy to maintain. And those definitely can be pros, and that looks absolutely amazing. That looks probably much better than the monolith that you've been dealing with for years. But if you're an experienced developer, you also then will go and realize that where there's pros, there's often cons as well. So you go and Google, what are the cons with microservices? And then you get things like this. They're difficult to observe, they're difficult to debug, difficult to deploy, difficult to maintain, difficult to understand, and difficult to deprecate. Now, you may have noticed that some of the lists, some of these items that are on the con list are also on the pros list. And I think that comes down to obviously your implementation of how you did microservices, but also the amount of teams that are working on the microservices. So when you talk about scaling microservices, there's two sides of scaling. So if we look at this example, we've got clients that are calling our application, and there's one team that's building this application. So normally when we talk about scale, we talk about this type of scaling, where we have more clients than usual hitting our application. So we need to now scale our application vertically or horizontally. And that's a very technical scaling issue. And for microservices, I find that this is less of, you get less value from microservices from this than you do from this type of scaling. So if you have the same amount of people coming to your app, but your product is growing larger and you're getting more and more teams, the application is much larger now, I think this is where microservices really shines. This is the true value, where monolith is horrid. If you have multiple teams working on a single monolith, I think that is very difficult to work on. So let's say that this is your ideal composition for microservice. This is where you want to go. If that's the case, I think this is the ideal reason to have microservices. If you've got multiple teams and each team is responsible for a separate microservice or a subset of microservices. It doesn't necessarily have to be one service, one team. You could have 2, 3, 4, 5 services per team, depending on the size of the services and the responsibility of the service. I do think it becomes a problem when you have a single team managing over 100 microservices. That's where you're no longer focused on the single aspect. So if you look at a single microservice, you can go, wow, this microservice is easy to deploy. It's easy to understand. I can open it up and there's very little code there. It's got a single responsibility. I can understand this microservice. And that's where you can say microservices are easy to understand. But the moment you have a single team looking at 100 microservices, now you've just taken this monolith that's difficult to understand and you've just made it harder to understand by putting a network in between it. That's where people say microservices are difficult to understand. So ideally, this is what you want. And then a front-end team, maybe some companies like having a separate front-end team or not. That's up to you specifically. So like I said, this is probably not what you want. You're going to have more issues than benefits when you have a single team running a massive amount of microservices. But what if the company said to you, but you know what, you're the team now that's going to build these microservices, and at a later stage, we'll hire teams and we'll grow into the microservices. My suggestion there would rather be, because I've been in that situation and the teams just don't come. Right? Like 2-3 years later, the teams don't come and it's still the same team managing everything, and it becomes really difficult. So what I would suggest here is to rather keep it as a monolith, and then where a single team can deploy one application and run a single process. This is a lot easier to work with. But then within that monolith, you break up the services how you would see them into just different modules. And those separate modules can operate as if they're microservices within that single process. And I think the big thing there, what you want to do is then just also have them speak to different data stores. So for example, if sales needs customer data, it can't go to, well, you design your system so it doesn't go directly to the database, but it would have to go through the customer module to get the data. So it would still have to filter through whatever business logic is here and stuff. So I do have a GitLab link there. We can drop that on the chat a bit later for you guys if you want to look at that. Some examples in .NET on how you could do something like this. A very basic, simple example of that. But now, once you've got this design and you get a new team, you can now go, okay, I think this will be a good portion to cut out for my new team. They're going to take over the customer segment. And then it's just as simple as pulling that out into a new process. And now you've got your two teams. The original team is still looking after the big bunch, and the new team is, because they're new developers, they just get a nice small section, and that's what they have to work on. But this shouldn't also stop a single team from decomposing further. You shouldn't necessarily have to wait for a new team to take over. So let's say the team has like some good reason to separate a certain piece of it. There's multiple different reasons. I think once you're in a situation like, you know what, this, when you're running it as a monolith, you'll have some sort of pain. You'll be like, you know what, this is becoming difficult. We need to pull this out. If you're not having pain, there's probably no reason for you to pull it out. So the team says, hey, this needs to be pulled out here. They can go ahead and just pull that out. So the team still has the autonomy to go and do that, and that can be pulled out behind the boundary of this product team. So the other teams don't have to even know that that team did that. And at a later stage, another team could take that over and become their own separate team that manages all that. So anyway, as you keep breaking these pieces up more and more and more, you land up reaching your ideal state over time. You may not reach this final state because you may get halfway and go like, you know what, we're comfortable here. This is a good point to be at. So the ideal services that you want to create at the end of the day, you can evolve into that, right? So the takeaway here is to start off simple and decompose later, evolve into where you want to go. Now, this idea of breaking up after the fact, you may realize that there are potential problems there, because if I have a single service and multiple people are calling it, and I decide to decompose that later and break them up later, well, now everyone else has to now change their services to now point to different places and make different calls and different messages, and now it becomes a big mess for everyone. So decomposition can actually affect other teams and other services. So we want to be able to keep it simple for everyone else as well. So let's go through an example on this, how we can go about doing this. So let's say we've got a bank monolith. So it's a single application. The company then decides we're going to do insurance as well. Sorry, so you don't want to, you want to go microservices now, so you don't want this big monolith, so you split them up. You have a bank and you have an insurance service. But then you find that the insurance company is, or the insurance service is constantly calling the bank service because there's a whole bunch of platform stuff there, the user data, which the insurance company needs very regularly. So it becomes this very chatty thing to the bank, which doesn't really make sense. So you split that up. I find this is actually quite common when you go from a monolith to microservices. You normally go to at least 3 because you'll have 2 different major ideas, and then you'll have whatever's that platform piece that sticks out. Now, this platform piece, I've been at companies where they'll create a separate team that would manage this, but in some cases, this stuff doesn't change often. It's created and it's done. So what may happen is that the bank team, because they created it, they understand it, they would own that. So they would own the bank and the platform. Okay, so now let's say the bank is calling the insurance service for some reason. I don't know why, but for some reason, it's calling the insurance service. But the insurance team decides they want to split this up. This is too much of a monolith for them. They want microservices. They want this to be split up into multiple services. Now, but you can see the client over here is calling it, the bank is calling it for a number of different things. So when you split it up, all of a sudden the bank team has to change their calls or their messages, however they're communicating, to accommodate for this new microservice decomposition that the insurance team did. But not only that, whatever the client is also going to have to change. And each of these services is now going to have to know about the platform service. So as you can see, this is why microservices gets very complicated, just because the amount of arrows that can end up pointing to absolutely everything. So a very simple solution that's worked well for one of the teams that I worked with before was we kept the original service exactly the way it was. So we had this monolith, or this big service that everyone was calling, and it knew how to call the platform. And this team now had the autonomy to decide how to break up everything they wanted without having to bother anyone else. So they could then just break it up. And these calls to this original, it would now be the gateway, doesn't change. So nobody's affected. So this team can chop and change and do whatever they want to these bottom services here without affecting anybody else. Now, there are some pros and cons to whatever you decide. So let's start off looking at the cons. Some people might think this is a bad idea because it's a single point of failure. This wasn't much of an issue for us because of redundancy. Obviously, it's a problem if you're only going to put up one instance of that gateway. If that falls over, then you can't access any of your services. Obviously, that's bad. Where if a single service fell over, you could still access service 2, 3, and 4. But with redundancy, you'd have multiple instances of the gateway across multiple geolocations, so that if one falls over, it's still fine. You can still access the other services. And this should be quite lightweight as well. So it's relatively cheap to have multiple instances. So the second point is you need to deploy your gateway when there are contract changes to a service it calls. So this gateway, it's calling service 1. And let's say it was originally calling a get with an ID parameter. But now the service is changing its get to a get with a name and a date. And it doesn't want this ID parameter anymore. That means that I must go to this insurance gateway and update its call to service 1. And I have to deploy both of them together. That is definitely a con of this, because now you've got to double the deploys and you've got to manage two things. But that's only with contract changes. If there isn't a contract change like that, you don't need to do that. So it's not, that doesn't happen as often as you would think. Okay, but the pros with this. Teams can use your service without requiring knowledge of the details. So originally, other teams would be like, I just call the insurance system and it does what I needed to do. But now when you split it up, you would have to tell other teams, oh, call this service when you want to do that, call that service when you need to do that. Now all of a sudden they've got a whole bunch of things that they need to concern themselves with, a whole bunch of new stuff. Where if you keep the contract with the other teams, like if you could think of the other teams as clients and you keep that contract exactly the same, they don't need to know about the details. So you can change this as you like without having to worry about affecting anyone else. Then these endpoints can be hidden away from other teams. So you can have endpoints in these services that you want to call amongst your services that they can call each other, but you don't want other teams to access it because it's not, you can think of it sort of like public methods and private methods in a way on a service level. So you can actually hide these behind some sort of network that they can't access it, that they only have this one place that they access your whatever you do. Then if a service contract changes but does not affect the contract of the gateway, it saves other teams from having to make changes. So if a team was calling this insurance gateway with, let's say, get ID, and that changed to get with parameter name, they would all have to change their call to this gateway, which is a headache. You want to affect other teams as little as possible. But if your contract changes here in the service, and it doesn't necessarily leak over to this one's changing its contract, so you change the contract on service 1, but this gateway can still accept the contract that's coming from other teams and fetch the required data to manage the contract change here, you can possibly not affect other teams. So sometimes this will leak over to other teams, but if other teams are calling the service directly, any contract changes will 100% affect other teams, where this level of abstraction may save them. Okay, now another solution I'm a little bit, I don't like as much, but some companies use it. They do like this approach, is that you would have a library. So the insurance team would create a library with their services, and that library would know how to call those services, in what order, when, and have all the knowledge of what to do there. And then the bank team can just install that library, call a method, and they don't need to know the details. And same thing with the client, it would just go off and make those calls. Now, again, there are pros and cons with this idea. So the cons, I feel like if you're going to do something like this, you need really good documentation, because they need to know what library to install, what methods to call. I think once at that point, the library itself, you would document inside the library and put all so they know how to use it. But I feel it takes a little bit more work to make this user-friendly compared to having a Swagger or something like that. Then the next thing is this may require more frequent updates. So it's very sensitive to changes. And if you've ever had to other teams to download and use your library and then update your library, you know how difficult this is. I think this is the biggest problem I have with libraries, is that you're like, oh, there's a bug here, I need to fix something. You change the library, and now other teams have to go and update their library and deploy as well. So all of a sudden, if you've got 10 people using a library, 10 people have to go deploy the application. Where if this was a service, no one has to do any deploys. It's just fixed the moment you deploy. So I think that's a pretty big con on why not to go the library route. And the other things, teams can still call your service directly. So I've had situations where teams are like, you know what, this library is annoying. I can see that endpoint, let me just call it directly. And because they're calling it directly, they can end up calling things they're not supposed to, that we didn't really want them calling, you know. But the pros, teams can still use your services without requiring knowledge of the details. Like we said, that's what we want to solve. So you can change these services up as you need, and that library will know how to manage the services. But obviously, if you decide to delete service 4, you can't just do it immediately, because everyone has to upgrade to the library first. So you would have to create your new service and get everyone to upgrade the latest library. And only once the service stops getting traffic, then you could remove it. So it is, again, much harder to use than having a gateway. But then services are independent and have no single point of failure. So yeah, because I think some companies have preferred this because of the idea that, well, if service 1 goes down, then service 2 is still operating. They don't have that gateway that they're worried about. If it fails, then everything is down. So just a quick review on what we've spoken about. Don't do big upfront designs. I'd say the biggest reason for that is that when you start designing something, that is when you know the least. And that's when you don't want to be making decisions. You want to make decisions when you know the most. So keep it small, keep it simple, make your decisions later. So in the beginning, rather reduce your complexity and let your system evolve. Often we have this perfect idea of what the system is going to look like, and it's perfect in our heads. And that's what we want to build. And it feels like we're not doing our best, or we providing something subpar when we make it simpler and we don't do that perfect system, but we've like just reduced the complexity and done something very imperfect, right? But I think that's the better way to go, because you're allowing it to be agile. You're admitting that, hey, I don't know everything right now, and I'm going to allow this to evolve and change as we learn more, as the team learns more, but also as the business learns more, because often the business comes with radically different ideas and changes as they go. So there, the idea is rather under-decompose than over-decompose. If you're not sure, rather, if you like thinking this service should be broken up into two, but you're not sure, like maybe it should be together, maybe they keep them together, rather keep them together than split them up. Yeah, so you're not 100% sure, rather don't split them. And the way you gain certainty on that is by creating modules within that single service. So just like you had that big monolith that you got multiple modules, you can create a single service that's got two modules because you wanted them to be two separate microservices. So they're two different modules, they have two different data stores, and you can test it out. And while you're working on that, you'll start realizing, hey, these are very, very chatty. Like if I had to break this up, this would be very difficult, because now all of a sudden I would need all these extra solutions. It's just not worth breaking this up. But as you're working on the system and it's in production and time goes by further and further, and you start realizing, hey, these things are completely separate. They're actually not talking to each other what I thought they might be. You're like, cool, time to split them up. And then lastly, consider the effects of others when you do change your services, because that is the biggest thing why microservices are difficult and why companies often do these big rewrites, is because changing the structure of services once they're in place is extremely difficult. Yeah, and that's me. Does anyone have questions?
All right. So we do have a question. So Nazir wanted to actually ask, he says, this is more of a brownfields question. Most systems are legacy with the intent of being decomposed into microservices. How do we manage distributed transactions or actions? For instance, a Saga having done multiple commands across multiple services, orchestration. If one command fails, how do we compensate if we are not using eventual consistency events? Are transactions frowned upon, or is there a better way?
Sure. Okay. There's quite a bit in that one.
Definitely.
So, yeah, the idea of distributed transactions, I would say avoid it as much as humanly possible. If you can completely get away from distributed transactions, do that. We know how to do transactions. SQL is absolutely fantastic at managing transactions. So if you have to transact, if you can stick it into a single service, that is your answer. That's not always possible, and sometimes you do need to have some form of Saga that will manage that. But you're saying, for instance, a Saga having done multiple commands across multiple services, one command fails, how do we compensate if we're not using eventual consistency events? Okay, so if you're not using events, I assume you also mentioned, you're saying messaging there. I'd say often when we say events, we use the same terminology for messaging. So I'm assuming you mean messaging here as well. So that would be like HTTP. You could then have a compensating event that's an HTTP endpoint. But yeah, again, I think these are solutions. I think the big takeaway should be, can you avoid that if at all possible? Sometimes it's not possible, and then like, yeah, you got to come up with very fancy solutions. And like, yeah, you could have a compensation action that is an HTTP request, but I would suggest figuring out how to get onto messaging there if you can as well.
Right, and then Michael van Niekerk has asked, how would functions as a service change the microservice architecture?
Sure. Functions as a service is not really my my expertise. I don't know if I'll be able to help you there. I think the idea is that functions as a service, you can maybe call it nano services, right? I don't know if you would agree with that. I kind of see that as like in being one service, one endpoint. For me, that creates a lot of complexity. I think using a function as a service works well for doing something that's not core to our business. Like if you want to send out, I don't know, like let's say an email or something, right? Something that's not really core. I'm very comfortable using that as just a function I want to call that's going to do some piece of work that's not core to my work. But yeah, I don't have experience in that. I don't know building an entire system with just functions, how that works out. Sorry.
I actually see Julian messaged us. He's covering that in the next talk. So we're going to all learn together on that. All right. Thank you so much, Brandon. That was awesome. I really, really appreciate it. We will be sharing the video afterwards. And if you guys have more questions, we'll also field them through. But thank you so, so much. It was absolutely awesome. And without further ado, we're going to hand over and let Julian take over and share a little bit more about some of the other stuff. Thank you so much, guys. Jules, over to you.
Okay, thanks, Anine. Let me just get everything up and running. 10,000 different windows open as usual.
I think that is officially the Julian way. We're going to brand it.
Okay, let me know if you can see everything. If it's okay, awesome.
Yeah.
Okay, guys. So today I am going to be talking about serverless platforms and specifically around functions as a service. This is a pretty short little talk, so I am going to cover quite a bit of information very quickly. Right, so as all talks, the best place to start is right at the beginning. So to give you a little bit of a brief history of servers, obviously in the 1940s, we had the emergence of computers and the ENIAC computer. I'm not going to go into detail. If you don't know what the ENIAC is, please come see me after the talk. In the 1950s, the guys who created the ENIAC then created the UNIVAC and started a company to sell this UNIVAC computer. In fact, the UNIVAC was the first commercially available off-the-shelf computer. Before that, any computer that you wanted, you had to build it from scratch. The company is actually still around. The shell of it is called Unisys today. In the 1960s, we had the emergence of IBM, and IBM released the IBM 360 mainframe, and that was really kind of almost a turning point in the use of computing on a mass scale. So this is when you see companies starting to build out systems and so forth using a digital computer. In the 1970s, things were getting smaller, and you had the emergence of mini computers. The one I want to talk about is the Digital Equipment Corporation, or DEC PDP-11. That was used to write the Unix operating system way back in the early 70s. In the 1980s, a very big event happened. You had the release of the Intel 386. The Intel 386 really is the first commodity CPU that was capable of performing complicated tasks. Up until then, the computing capacity that you had on your desktop PC sitting on your desk was pretty limited. But the 386 was kind of almost a revolution in commodity chips, because now you could actually do quite complicated tasks, and this led to the creation of PC-based servers. And this is really where you see the explosion of commodity-based computers that you would use to do your typical server tasks, such as run transactions, manage files, do print jobs, etc., etc. Now, in the 90s, computing capacity was obviously growing quite tremendously. Moore's law is still in effect, and people started running into a little problem. So they had all these little commoditized servers running, but they weren't being used effectively. So enter VMware, and VMware is basically the first virtualization platform for Intel-based systems. In the 2000s, you had, with the ever demanding requirement to maximize the amount of compute that you're using, you had the introduction of container-based systems, and the first one really that was mainstream was Solaris Zones, which was obviously part of the Solaris operating system released by Sun on the Spark platform. And it's kind of a predecessor to Docker and to a certain extent Kubernetes. Fast forward into the 2010s, and we have the emergence of cloud, where compute is heavily commoditized. And with that came the emergence of functions as a service. And this is pretty much what we're going to be talking about. So what are the benefits of cloud? All right, so to take a step back, commodity service left us with quite a great mess in terms of how we actually run programs in our data centers. For a start, especially in the early years, you couldn't scale up, you had to scale out. So if you wanted to increase your capacity, you basically had to create another server and add it into your data center and then run your applications on there. So the very nice problem that this left us with is the need to do distributed computing en masse. And to sort of paraphrase the expression about regex, I try to solve my problem with another thread. Now I have two problems. But certainly the worst crime that this commodity computing really gave to us is the fact that the actual computing capacity that is available in your data center was heavily underutilized. So if you think of something like a print server, guys are maybe printing on that 3 or 4 times an hour, and they don't print after hours. So at the same time, your little server is running there doing absolutely nothing, just basically adding new greenhouse gas into the atmosphere. And obviously now people started introducing a lot of the features that were available in the mainframe. So one of the key things is the idea of virtualization and the hypervisor that actually came from mainframe. So this is where the impetus came to actually start reintroducing these type of solutions to maximize your computing on commodity systems. And containers really is kind of the next step to that, where you have a very lightweight container to maximize the amount of compute that is available on your commodity server. And functions as a service really is kind of the cloud-based attempt to do this massively distributed computing within a cloud environment. Okay, so what is a function? You'll normally see functions denoted with the lambda symbol. This is obviously a reference to lambda calculus. One of the features that's important, and it certainly carries over if you're doing functions as a service, is that functions are stateless. Functions as a service really takes the concept of stateless functions and provides a massively distributed way to invoke those functions that you write. The idea for this is actually not very new at all. So it originated in mainframes. What you see there is basically the Kix middleware, and some of the developers watching this are probably familiar with having to do integration in the banks where you've got to integrate into old Kix COBOL systems. Kix was basically a multi-language application server for the mainframe. You could actually write your functions or tasks, as they call them in Kix speak, in many different languages, although in practice, most of the people just use COBOL. The Kix environment will actually go and make sure that you have that your task executes in its own isolated memory space. Kix does the task of actually scheduling and prioritizing how your tasks optimally run on the mainframe. And it even can allow you to cluster two mainframes together and distribute execution of a specific function across different mainframes. The first version of Kix was released about a week before Apollo 11 went into space. So that actually tells you how old these ideas are, and it kind of is kind of sad that we haven't really moved past ideas that were come up with by the mainframe guys. FAS basically takes the same approach. It creates a massive scheduler that takes your function code, and if you try to invoke that, it then goes and decides where within its big pool of computing resources within the cloud it needs to go and invoke that. There's currently, each of the big three cloud vendors have got their own implementation of this capability, this function scheduler in the cloud effectively. So you have AWS Lambda, which is the oldest of the three and is definitely the most mature. And then obviously you've got Azure with its Azure function, and then Google with its Google Cloud functions. One thing I do want to highlight, functions as a service is still relatively new. And there aren't any existing standards that allow you to easily port a function that you write for one specific cloud platform into another cloud platform. So if you, for example, you want to write a Java function, there's different ways on how it gets managed between Lambda and Azure, for example. If it's portability you want, there are patterns for how to do it, but it's not, serverless currently isn't the best way to achieve portability for your application. Going a bit forward into what a function or a serverless function actually looks like. So this is an example on the screen of what a serverless function is. This is effectively a bit of Python that takes input in the form of an event, and then goes and takes the data associated with that specific event and writes it into AWS's blob storage system, which is called S3. And that's it. This code here represents the complete amount of coding that you need to do, besides obviously packaging, uploading, and configuring your function, what you need to do to actually write a serverless function. So it's, for the most part, this is pretty much plain old Python code. In addition to this, there's a couple of things that you will get out the box once you actually run this inside your AWS Lambda environment. So one thing you can do is set retries. You can set the amount of times that an invocation is retried on a specific function. And obviously with the retries, you need things like dead letter queues in order to manage events or manage invocations that have now timed out, seeded their retry times. You need to, it gives you logging out the box, it gives you tracing out the box, and it gives you code versioning out the box. So you can actually manage the versions of your Lambda functions within the cloud, and AWS pretty much takes care of everything. Okay, so some of you might be asking, well, doesn't Docker and Kubernetes give us the same type of functionality? Okay, so first of all, Docker still needs an execution environment. Now, obviously that's provided by something like Kubernetes, but you still need to decide when you create a Docker image, how you are going to run this, where you're going to run this. And it is worth mentioning that Kubernetes is considered a serverless environment, but the reality is with Kubernetes, you still need to manage some infrastructure. In the case of, for example, the AWS service, you need to manage the computing pool that's supporting your Kubernetes infrastructure. So if I want to say, I need to say I've got 4 or 5 servers, and this is forming the pool of compute that's available to my Kubernetes environment. If I want to expand that, then I have to expand my pool. AWS, though, it's worth mentioning, they have a service called Fargate, which kind of takes the complexity out of it. So you effectively upload a Docker image, and it goes and decides how it's going to execute this Docker image for you somewhere. You still have to create and manage Docker images in a registry somewhere, and you generally have to provision or use a service of a registry somewhere in order to use Docker. And you still have to create and manage the additional services that are around your Kubernetes infrastructure. The most notable one being something like login, where you still have to go and integrate your Kubernetes infrastructure into something like Elasticsearch and Kibana. And if you want to build a service mesh, you have to provision it yourself. So you now need to build those images, package your code, integrate everything, and then deploy it on your Kubernetes environment. Now, if you contrast this whole Kubernetes environment to FAS architecture, I actually don't know the details. Now, AWS, for example, does give a very high level architecture of its Lambda environment, but to a certain extent, I actually don't care. I don't need to care. All I need to know is that I can deploy my function and I can invoke it. The cloud effectively takes care of managing the invocation of that function. It already provides me with all the additional service. The Lambda environment that is provided by AWS effectively gives me a full service mesh. And in terms of my payment, I'm only paying for the amount of time and memory and CPU that my function uses while it's busy executing. So I'm only paying for what I use. So for example, if I have a service that only gets invoked 100 times a day, I'm only going to pay for those 100 invocations. I'm not going to pay the cost of the server that's running 24/7 for 100 invocations. Now, skipping forward onto the architecture that you would typically apply when you're building a serverless environment, it's pretty simple, pretty similar to what you might see in a typical microservice environment. And the question was asked in the previous talk is could you use functions as a service to implement microservices? The answer is actually yes. You decide on the granularity of how big you want your service to be. And that's really a decision you can make. So you can create a nano service, and you can create a larger, more coarse-grained service that does a bit more. There are some patterns around how you might use microservices specifically in a serverless environment that you can maybe go look up some time. And obviously the same rules around good software design still apply when you're busy designing your function. Now, for most of us, we don't really have simple functions. You know, there's a whole bunch of layers that you normally have to try and invoke in order to make your function work. And really all those principles apply. So you must decide, there is still an element of design, and you still have to go and decide how best you're going to package and utilize your functions. Now, one thing I will say, however, is that your code is still a binary, and a binary still needs to start up and execute at some point in time. The larger you make your binary, the more dependencies it has, the longer it takes to start up. So there is kind of a trade-off. You can, if you want to. If you wanted to, you could create a big, massive monolithic microservice. So your entire monolith gets invoked every time you have a function invocation for one single function. Of course, you wouldn't want to do that. And certainly one of the things that's going to bite you very quickly is that your binary is going to take a long time to connect. So for example, if you've got a monolith that needs to connect to 2 databases, you are going to incur the cost of 2 database connections as your function as a service spins up in order to execute. And another thing I want to mention here, and it is a bit of a gap, is that currently functions as a service aren't suited for batch processing. Now, if you think about it, it's the same as if you're using, say, your pay-as-you-go cell phone. If you use your cell phone a lot, it starts becoming cheaper to actually go onto contract rather than just buying airtime. And a similar type of thing applies currently. It's not saying that you can't overcome this problem, but currently, as it stands, it becomes cheaper to buy a dedicated chunk of computing for a certain amount of time to do a batch process, rather than building this big batch process inside a bunch of functions. Okay, so a couple of interesting things, and to a certain extent, this reflects both the newness and the kind of trajectory of use cases of where functions as a service are going. Now, the two languages that we use the most, and is probably still the most widely used within large enterprises, is obviously Java and .NET, and they're sitting right in the bottom of the specific set of graphs. There's some other benefits that you obviously get. So, for example, Go, Python, and Node.js are quite compact, and with Go being native, and with both Node and Python executing immediately as soon as the parser is able to execute code, you do get quite fast startups. So there are some benefits to these environments, and because of the short running executions, you don't always get the benefit of an adaptive compilation like you would have in a Java environment. But certainly the biggest thing is that big companies aren't using this at scale yet. So, any questions?
All right, we have a question from David, who's asked, do you have any tips to help alleviate a client's fear of being tiered into one provider? How would you deal with that?
Okay, so well, the simple answer is that you solve, you create a layer of indirection. I mean, if you look at the kind of contract that most of these providers have, it's not impossible to create a library which kind of minimizes the amount of direct coupling you have. And I mean, I think you're actually going to get more coupling if you start using the native services. For example, if you use DynamoDB, because there is no equivalent. Well, there is an equivalent, but not a binary compatible equivalent, or an API equivalent that works in other cloud providers. So, but I mean, if you're calling like a relational database, you can create a kind of a portability library if you want to.
Awesome. And then Michael actually asked, how does Knative/OpenFAS fit into this?
I'm not that familiar with that. I can't answer that question, sorry.
Alrighty, so a little bit of research there. Thanks, Michael. And then Malcolm would like to know, where does Apache Kafka fit into this?
Well, Kafka is basically distributed streaming message bus, and it's really used to do massive volumes of streaming data, and that's really what its major intent is. So you could, for example, build an event-driven architecture that uses Apache Kafka as a backbone. Where it's seeing more use is generally in analytics. Certainly, all the clients that we've been at that is using Kafka are using Kafka for doing almost real-time analytics. To get stuff into to get data into their data lakes very quickly.
All right, and then
it's worth mentioning. You might sorry, Anine.
No, go for it. Go for it.
Yeah. It's worth mentioning as you might have a Lambda function which publishes a message to an Apache Kafka topic.
That's actually a great point. Thank you. And then one last question before you wrap up. Gillad's asked, what are your thoughts regarding Go as the new contender to some of the old de facto languages? Do you think Go is going to be more widely adopted and progress into the future?
Okay. So I decided a couple of years ago that I'm not going to try to do too many predictions about programming languages, because inevitably they end up being wrong. What I can talk about Go. So Go's got quite a few advantages over something like .NET and Java. First of all, it's purely native. It's pretty fast, and it gives you a lot of the benefits that you would have with a higher level language such as Java and .NET. So, for example, by comparison to something like Rust, Rust has got a lot is built for a lot lower systems programming. So for example, I'm not sure if I would use Rust for building APIs. However, Go I would use for building APIs. So that's kind of where we're seeing a lot of adoption. And obviously, it's as an API, it's being used in places like AWS Lambda.
Okay, no, that's awesome. Thank you so much. All right, everyone. I think from our side, thank you so much, Julian. Thank you, Brandon. We have had a really interesting session. I'm going to hand over to Julian to close us out, and then we'll go from there.
Yeah, okay. So basically, what Functions as a Service gives you is a massive amount of distributed computing capacity. And the cloud effectively becomes a scheduler that allows you to manage your compute and maximizes the amount of compute that you are using. So you pay exactly for what you use, not what's busy creating greenhouse gases. As a capability, it's still pretty new. So beware if you do start adopting it, because there isn't really much in the way of standards yet. But obviously the biggest benefit that you get out of all of this, and certainly for a developer, is that you no longer have to care about the underlying infrastructure. The cloud really takes care of everything for you. And that's pretty much it. Thank you.
All right. Thank you so much, Julian. Thank you, Brandon. This was awesome. We will be wrapping up this session now. All of the content will be published on our YouTube channel. Go check that out. And otherwise, have a fantastic one. Please stay safe, take care, and we will see you guys very soon. Goodbye for now.